Okay, on problem number 40, and it looks a little strange. It's minus x squared, and then you got minus 40x, and then you got plus 50. All right. One thing I'd recommend the problem, not that it's absolutely essential, but I think the fact that the coefficient on the square term is negative is going to make it more difficult for me to deal with it. So what I'm going to do is I'm going to factor out minus 1. And what do you get there? You get x squared plus 40x minus 50. And again, I'm going to try it. Minus 1, x and x. And it should be easy, by the way, but unfortunately I'm looking at 50, and just looking at it, I'm going to say 50, 2 and 25. So I'm not going to give you 40. What else could you do? 10 and 5. I think you get the idea that, 50 and 1, nothing's going to work, by the way. So my suspicion over here is that this does not factor over the integers. So let me erase this over here. And I'm going to say this guy here does not factor over the integers. I'll write that down for you. Does not factor over the integers. Again, if you're not ready to go here with looking for roots using the quadratic formula, you'll have to wait. But I'm going to use the quadratic formula to find the roots, and then we'll be able to factor the problem, by the way. All right? So let's write this down. I'm writing minus x squared minus 40x plus 50 equals 0. I can multiply both sides by minus 1 just because of the preference I have, by the way. This is an equation. This is not a factorization problem. It's going to be plus 40x minus 50 equals 0. I can use quadratic formula. X equals, kind of nasty numbers, by the way. Let's see, twice a goes on the bottom. That's 2. The opposite of b minus 40 plus or minus, these are really nasty numbers, by the way. 40 squared, that's the b squared, minus 4 times the a, which is 1, times the c, which is 50, minus 50. So I'm going to put 50 here and change the sign. I think I'm ready to do some arithmetic now. And again, it looks nasty. There's a 2, minus 40, plus or minus. Well, that's going to be 1,600. And then what do you get there? Let's see, 200, right? What's that going to be? X equals. And again, if you're not prepared to go here, you're going to hold off on doing something like this. Just simply list this as your answer, by the way. Like does not factor over the integers. You gave it a try, it didn't work out. 1,800. And I'm looking at 1,800. I want to point out what I mean by that. I'm looking at it. I definitely see 100, and then I see 18. Now, someone says, why are you looking for 100? It's a perfect square. I would also see a 9 times a 2. Let me write this down then. I get minus 40 plus or minus. Well, the square root of 1,800 is going to be the square root of 100, which is 10, the square root of 9, which is 3, so I get 30. And what do we left off with? Root 2. This is all over 2. Let me keep writing this down. X equals minus 20 plus or minus 15 root 2's. All right? Kind of nasty, isn't it? So what I'm going to do now is kind of write it down. What do you get over here? X plus 20 minus plus 15 root 2. All right, so I know this equals 0 now. And these are roots. I'll write this down, and then we'll look at the problem. There's an issue with it, though. Don't worry about the issue yet. I'm going to write this down. 20, I'm going to say minus 15 root 2. And the other one's going to be x plus 20 plus 15 root 2. What's my claim? This is equal to the original problem, which is minus x squared minus 40x plus 50. And the truth is it's not equal to that. And why is that? If I just thought about it, x times x would be x squared. What do I need? A negative number. So let me just cross this out, and I have to rewrite this thing over here. This is the original problem. And I'm going to say it's minus, let's write this down, x plus 20 minus 15 root 2, x plus 20 plus 15 root 2. I could put a box in this indicating I'm done with it. Someone says you're going to check that out. Not really. I don't want to check it out, but I do want to look at the answer key. And someone says, why do you do that? I want to see what they have for an answer. right? So I'm looking at number 40. This is problem 40. What am I seeing over here? Well, I'm seeing I'm seeing this. Now, granted, it might be jumbled, but I'm seeing it. I'm seeing 15 root 2. I see plus 20. I see plus x. And then I'm wondering, I don't really see this over here. What do I see? I want to point out what I'm seeing over here. What I'm seeing is 15 root 2 minus 20 minus x. Is it the same thing? It is. This and this are identical. What do? You distribute the minus 1 across those three terms, you would get minus x minus 20, and you get 15 root 2's. So my answer is good. It stands to reason. Thank you.